Hi everyone, this is Mr. Muhammad and I'm going to show you how to solve some of these examples so you can actually practice more at home. So the first one, I have 36 to the power half, and if you remember correctly, we learned that power half means 36 to the power 1, and the index of the square root will be 2. But at the end of the day, we do not write power 1, so I'm going to erase this, and we do not write power 2. So I end up with the square root of 36. So you ask yourself a question, what a number, if I multiply by itself, I get 36? And the answer is 6, because 6 times 6 is 36. So 36 to the power half is essentially 6. And then you move forward, 27 to the power third. So it can be written like this, 27 to the power 1 over 3. But also you don't need to write to the power 1, so we can erase that. And the answer to this question will be, what a number you multiply by itself 3 times to get 27. And the answer is 3, because 3 times 3 times 3 is 27. The next question, 49 to the power half. So 49 to the power half, the same idea, so it's just like root 49. So what number you multiply by itself, you get 49, and the answer will be 7, because 7 times 7 is 49. And that's how you solve normal roots like this. So let's move to another idea. If you have a variable within the brackets, I want to change this from radical form to exponential form. So the first one is the cubic root of a squared. That's how it's read, the cubic root of a squared. So how we do this, you are going to use this formula we learned before. It says if you have x to the power n to the index m, you can write it as x to the power n over m. So let's do this. So cubic root of a squared will be a to the power 2 over 3, because n in this case is a and m the index is 3, so it's a to the power 2 over 3. And this is the simplest form in the exponent form. Next one is the cubic root of a all to the power 2. So there's many ways actually to look at this one, but the easiest way is to work from inside out. And that means I will keep the bracket squared, and I'm going to change what's inside to exponent form, which will be a to the power 1 over 3. Let me write this again. Yeah, a to the power 1 over 3. But then you remember also we learned another rule, which is x power n all power m equal x power n times m. So you multiply the powers. So this one will be a to the power third times 2. So it's a to the power 2 over 3. Next question, I have c squared under the fourth root, so essentially it will be c to the power 2 over 4, and you can simplify that by saying the 2 over 4 is actually, it's actually 1 over 2. One more, I have 5xy to the power 6 under the cubic root. So you can also work from inside out. So it will be 5xy to the power 6 over 3, which will be 5xy all to the power 2, because 6 over 3 is 2, and that simplifies to 25x squared y squared. And that's your final answer. Let's see some more questions. I've got here multiplication and division problems. Same idea though. Here, as you can see, you have two brackets. One of them is the fourth root of 6, and the other one is the third root of 6. So normal multiplication is not going to work like what we learned. If you have the same index, and I'm going to write this down, if you have the index n, and this is x, times another root of index n also, you can take this index n and multiply what's inside. But that's actually not the case that we have here. So I'm going to erase this rule right now because that's not going to work in this example. But what's going to work though, what's going to work is if you change both of them to exponent form, and then you can actually multiply them by adding the powers. Because you know that x power n times x power m is essentially x power n plus m. Then you add the powers. So let's do this. So it will be 6 power 1 over 4, 6 power 1 over 4, that's the first one, times 6 power 1 over 3. And to simplify this, you can add the powers with the same base. So I check they have the same base, so I add 1 over 3 plus 1 over 4. So 1 over 3 plus 1 over 4 gives me 7 over 12. 7 over 12. And if you want to do this on a side, let me show you. You do 1 over 4. Oh, wait. 1 over 4 plus 1 over 3. The problem is they don't have a common denominator, but the common multiple of these two numbers is 12. So it will be 4 becomes 12 when you multiply by 3. So you multiply up by 3. And then 3 becomes 12 by multiplying by 4. So you multiply up by 4. And you add both of them, it will be 7 over 12. And that's how you do it. The next question I have the 9th root of y power 3 divided by the y power 9 of the cubic root. The thing is, also they don't have the same index, so normal division is not going to apply. So what you're going to do is going to change both of them to exponent form. That becomes y to the power 3 over 9. And the other one is y to the power 9. That's not a good 9. Power 9 over 3. And that gives you y power 3 over 9 is 1 over 3. And this is y power 3. So if you simplify this by minusing the powers, 1 over 3 minus 3. So it will be 1 over 3 minus 3. It's minus 8 over 3. And of course we don't like the negative exponents, so I'm going to make it down as 8 over 3, positive. Okay, next question is root 5 times the 5th root of 5. Same idea, they don't have the same index, so we can't solve it normally. So we're going to make it 5 times 5 to the power 1 over 5. 5 to the 1 over 5. No, this is 5. Okay, so by adding the powers, of course, this is 5 power 1 over 2. So it will be 5 power 1 over 2 plus 1 over 5. 1 over 2 plus 1 over 5. So if you do this, you're going to get 7 over 10. 7 over 10. Okay? So this is easy because it's quick. Okay? Next one is the 7th root of 7 times the 3rd root of 7. So it will be 7 power 1 over 7 times, that's not good. Let me erase this. Go back. It's red. So I have 7 power 1 over 7 times 7 power 1 over 3. And after checking, you see that you have the same base. Both of them are 7. So you take this base and you add the powers. 1 over 7 plus 1 over 3. So 1 over 7 plus 1 over 3. So you end up with 10 over 21. So 7 power 10 over 21. And that's actually how we solve these kind of problems. And remember, if he asks you to multiply, to change from exponential to radical, you have to have the answer in radical form. But if they ask you to change from exponent to from radical to exponent, then the answer must be left in exponent form. As you can see, all the answers I put right here are in exponent form. So if you have any more questions, please reach out to me via email.